Hello, Algebra 2 folks, and welcome to Solving Radical Equations. We're going to apply our knowledge of what we have learned throughout the whole chapter about roots and exponents so that we can solve equations. And remember, equations have an equal sign. You're going to need your notes, a pen or a pencil, and some kind of calculator, and maybe even your handy-dandy yellow sheet. All right, so here we go. What is solving equations entail? What do they involve? Well, one of the things that, and the most important thing, is to get that x variable alone. That is our main goal, is to get x alone. And how do we do this is that we use these inverse operations that allow us to move things from one side of the equation to the other. So adding and subtracting are inverse operations, multiplying and dividing, square rooting and squaring, cubing and cube rooting. So with the help of inverse operations, we are going to get that x variable alone. We do need to make sure that we check our work and our solutions because sometimes we get extra solutions. Remember, we called those extraneous solutions that don't always work. Even though we found them, they just don't work in the equation. So always making sure we check our solutions. All right, let's go ahead and get started with example number 1. The cube root of x minus 9 equals -1. We're going to isolate the cube root of x by adding 9 to both sides. Inverse operations cancels out. We have the cube root of x equals 8. The inverse of cube rooting is cubing. So I'm going to cube both sides. The cube root and the cube are going to cancel each other out, and we're going to be left with x equals 512. Now, before we decide that that's the correct answer, we really should check our work. So I'm going to put this cube root of 512 back into the equation, and then subtract 9, and hopefully it will equal 1. The cube root of 512, if you're looking at that handy dandy yellow sheet, is 8, and 8 minus 9 is -1. So it checks out, therefore 512 is the solution. All right, let's try another one. 2 times the cube root of x minus 3 plus 7 equals 11. Okay, the first thing we got to do is isolate this radical. Got to isolate that whole thing. Now, sidebar, if I had 2x plus 7 equals 11, I'm pretty sure that most of you would tell me, oh, go ahead, Mrs. Brendan, and subtract 7. You would be right. And then you would be dividing by 2, and you would get an answer of 2. But now that this x has changed into this radical, we're going to do the exact same thing we did over here, except in the end, we might have to change it a bit. So, first step, subtract 7. Subtract 7 on both sides. 2 times the cube root of x minus 3 equals 4. Okay, again, trying to get that radical alone. These guys are being multiplied, so we're going to divide. The cube root of x minus 3, because the 2's cancel out, equals 2. The inverse of cube rooting, again, is cubing. So I'm going to cube both sides. I get x minus 3 equals 8. Add 3 to both sides to finally isolate that x. And we're going to get x equals 11. Now let's make sure it works back up into the equation. 11 minus 3 is 8. So 2 times the cube root of 8 plus 7. Does that equal 11? Cube root of 8 is 2. 2 times 2 is 4. Add that 7. And yes, it does equal 11. Therefore, the answer is 11. Okay, let's try another one. This says the cube root of x minus, the 2x plus 3 is equal to the cube root of x minus 1. So if you notice, they have a radical on both sides. So if I were to try to eliminate the radical by cubing one side, I would have to do that to the other. And what is going to happen is that the cube roots and the cubes on both sides are going to cancel. And you're going to get 2x plus 3 equals x minus 1. So we have a cube root function here that turns into a linear problem. How do I get x alone? Well, I'm going to get x's on both sides from one side to the other so they're both on the same side. And I'm going to get x plus 3 equals negative 1. And I'm going to go ahead and move that 3 over, and I get x equals negative 4. I'm going to check it back up into the original problem. So the cube root of negative 4 times 2 is negative 8, plus 3 is negative 5. Am I going to get negative 5, the cube root of negative 5 on the other side? Let's see. Negative 4 minus 1. Yep, it's cube root of negative 5. That checks out. This is the solution. X equals negative 4. Okay, let's try another one. So same idea of what we just did in that last one, but now we're dealing with square roots. I know that's a squared because my index isn't there. If I were to square both sides, this gets a little tricky. The square and the square root cancel, and I am left with 7x plus 15. However, when I take x plus 1 and square it, remember that means x plus 1 twice. And then I have to FOIL or double distribute. So x times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. Now if I'm going to combine like terms, I have x squared plus 2x plus 1 equals 7x plus 15. Well, we need to be cautious here. We have a problem. We don't have an x to the power of 1, we have an x to the power of 2. And that's a quadratic equation. How did we solve quadratic equations? Well, I remember talking about 3 or 4 different ways, but we're going to only focus on the 2 ways. One, we'll focus on maybe being able to factor it. Now that's not always going to work, but it's nice to always try to see if it's factorable. If it's not factorable, we're going to use the quadratic formula. Okay, so the first thing we're going to do is try factoring. If factoring doesn't work, then we're going to go to the quadratic formula. And in order for us to solve a quadratic, we have to get everything on one side. So everything over here is going to be moved to the other side. So I am going to end up with x squared minus 5x minus 14 equals 0. Now, this is in standard form. I'm going to try to factor it. If I can't, again, I'm going to use the quadratic formula. So this is a trinomial. How do we factor a trinomial? We use the AC method. 1 times negative 14 is negative 14. 2 factors of negative 14 that add up to be negative 5 would be negative 7 and positive 2. So then my factors are going to be x squared minus 7x in our squares. Remember, you're going to factor out the top, you get an x. Factor out the next row, you get a 2. First column x, second column negative 7. So the factors of this problem would be x minus 7 and x plus 2. Now, if you remember from chapter 4, we set each one of those equal to 0, and we solve. Okay, so now I have 2 solutions. Before I say that they are both the solutions, I'm going to go ahead and check them back into my problem, my original. So 7 plus 1 is 8. 7 times 7 is 49, plus 15 is 64, and the square root of 64 is 8. So 7 really does work. Let's try negative 2. Negative 2 plus 1 is negative 1. Can I ever get a negative when I square root? I don't think so, but let's try. 7 times negative 2 is negative 14. Negative 14 plus 15 is 1. The square root of 1 is 1. Yep, that doesn't give me a negative 1. Therefore, negative 2 does not work. That is an extraneous solution that we found that doesn't work. All right, well, that ends today's lesson. I will come back tomorrow and we will try practicing more. Thank you for taking good notes. We'll see you soon.